Hello students, in this video we'll discuss the limit comparison theorem. The limit comparison theorem states the following. If you're given two sequences of positive terms, an and bn, and the limit as n approaches infinity of an over bn is equal to L. So this limit, i.e. the limit of these sequences, exists, then the sum, n goes from 1 to infinity, of an and the sum from 1 to infinity of bn converge or diverge together. In other words, if an is convergent, then bn will converge, and if bn is convergent, then an will converge. Or if bn is divergent, then an will diverge, and vice versa. So let's see an example of this. Let's show that the sum, n goes from 1 to infinity, of the sine of 1 over n will diverge. And so what we'll do is we're going to consider a sequence bn, which is 1 over n, and we know the sum from 1 to infinity of 1 over n diverges. And now we're going to compare the sequence an, which is the sine of 1 over n, to bn, which is 1 over n. So if I consider the sine of 1 over n over 1 over n, and I take the limit as n goes to infinity, well, what would we get? We would get the sine of 0 over 0. So this is our form. So this, of course, is indeterminate. So what we'll do is we'll use L'Hopital's rule. So by L'Hopital's rule, this is the limit as n approaches infinity of the derivative of the top with respect to n. So that'll be a cosine of 1 over n times negative 1 over n squared. And then the bottom will be a negative 1 over n squared. So those negative 1 over n squareds cancel out, and you're just left with the limit as n approaches infinity of the cosine of 1 over n. And we see that this is the cosine of 0, and the cosine of 0 is equal to 1. So this limit exists, and since this limit exists, and we know that the series of bn's diverges, we conclude that this series over here will also diverge. Now we can see the next version of this. The limit comparison theorem also tells us two other things. It tells us that if I look at the sequences, if the limit as n approaches infinity of an over bn equals 0, and the sequence bn converges, the series bn converges, the sum from 1 to infinity, then the series n goes from 1 to infinity of an converges. And so the point now is that if this is going closer and closer to 0, then the an is being controlled by bn. So for example, if we look at the limit as n approaches infinity of the series 1 over n squared over 1 over n cubed, we see that this limit If we put a 3 up here and a 2 over here, let's see what happens. So if I flip this, I'll have the limit as n goes to infinity of n squared over n cubed. And so we see that this is equal to 0. And we know that this series in the denominator converges over here. And so therefore this series over here will converge. So since n goes from 1 to infinity of 1 over n squared converges, this implies the sum n goes from 1 to infinity of 1 over n cubed converges. Thank you very much.